MQTT stands for Message Queue Telemetry Transport. It was initially introduced in 1999 and it later got standardized in 2013. Now it is a ISO standard. It is a publish-subscribe based lightweight messaging protocol used in conjunction with the TCP/IP. MQTT is lightweight protocol suitable for resource-constrained environment, especially harsh environments with low bandwidth connections such as oil and gas industries. It has been designed to provide connectivity between embedded devices and middleware, IoT middleware. Basically, it is good at sending status update of sensors to the IoT middleware. MQTT architecture comprises of three components: publishers, subscribers, and message brokers. So publishers are the client, they are the lightweight sensors. Subscribers are also clients who subscribe to a particular type of data, and message brokers are the server. So basically, assume that in an oil rig, you have certain type of sensors sending data to the application or the middleware or the server. And then any application interested in getting access to a particular type of sensor like temperature, they can sign up saying, hey, I want to see the temperature data. And then as soon as the data coming in, the broker will forward the data to the whoever subscribed to that particular data type. So we call it topic, which means, for example, topic humidity is a topic that you can say that is the interesting topic that I want to access to. So any data items tagged as temperature would be forwarded to the that client who subscribed to the topic temperature. There are a few characteristics of MQTT. So the message broker controls the publish-subscribe pattern. Topics are used to annotate data items as well as to express interest. And they are designed for remote connections, low bandwidth, small code footprint, because to send a MQTT message, you only need a very small amount of computation on the sensor side. To understand how the MQTT works better, please now go and watch the video I have put here. MQTT has 5 different methods: connect, disconnect, publish, subscribe, and unsubscribe. You can see that the same methods in the figure as well. In the figure, client B is a sensor, client A is the one that looking for data, or maybe application. So the application first connect to the broker, and then the broker will send acknowledgement. After that, client B publish temperature data, and then the broker retains that data item, and then after some time client A, this is the application, subscribe to temperature data in the roof, and then the broker already have that because it previously got from client B. Now it sent to the client A. Client A can publish data as well. Then after that, client B publish another piece, 38. Now it is already subscribed client A, and then it directly sent to the client A now. And then you can disconnect client A if that is the end of the request of the application. MQTT use a publish-subscribe architecture. In contrast, HTTP use a request response, which means that I am requesting a particular website, and then the web server will send me back the response. That is the request response. But publish-subscribe means that publisher publish data, whatever the data they have, and then as the subscriber, I can subscribe to any particular topic that I'm interested in. So if someone publish that particular topic, I will get a notification as well as the data. So this is event driven. because the event is that someone actually publish a topic that is interested to me. So if that happens, I get the data. So in this architecture, the messages are pushed to the clients who are interested in or who have expressed their interest. This adopts the centralized communication because MQTT broker is the centralized component in charge of dispatching all the messages it gets to the rightful receivers. Each time any of the client publish a message, it has attached to a topic. So the topic is the one that used by the broker to forward the message to the expressed clients. MQTT uses TCP's reliable communication. At the same time, it also has transport layer security, but TLS will add overhead to the communication of the MQTT messages. Because of the broker, the client don't have to know each other. They only communicate over the topic. This architecture is highly scalable because the clients can be very thin and resource constrained. You need to have a well-resourced broker because the broker does the most difficult of the computation intensive job of collecting data and keeping them in the buffer. But the clients who publish or subscribe don't need to have much computer resources. It is important to note that if you think that your IoT system require MQTT, you don't need to write any of the code because all the client side and the broker side, there are open source software people have already written. You just need to deploy them and configure them. And for the client side, there are a lot of different frameworks written by different languages that would fit in from microcontrollers to the mobile phones to or any Windows or Linux or any kind of environment. So everything we talk about MQTT here are already implemented and you can just use them. A topic in MQTT is a string that has hierarchical levels which is separated by a slash. So if you want to refer to temperature in a living room in a house, you can use house/living room/temperature. From the subscriber end, you can subscribe to a specific hierarchy, or you can use wildcards like plus sign. So if you put house/plus/temperature, that means all the messages sent previously to house, but it could be in any room and then slash. All the messages will be forwarded to you because the plus will be replaced by anything. So it's more like a variable X. So the living room, kitchen, garage, or anything. You can also use hash. Hash means rest of the string hierarchy. All the combination of the rest of the hierarchy will be forwarded to you. There are 3 levels of quality of service in MQTT protocol: QoS 0, QoS 1, and QoS 2. QoS 0 is also called at most once, which means that a publisher's message is sent to the broker once, but they do not send any acknowledgement. And then the broker send that information to the subscriber. Again, there is no acknowledgement, which means that both transmissions are not acknowledged. QoS 1 is also called at least one delivery. Here both publisher and subscriber do acknowledge when they get the data. QoS 2 is called exactly once delivery. In this level, both duplication and loss are examined and eliminated by two-way acknowledgement in each part of the communication using a packet identifier. However, this will increase the overhead, but it will guarantee the data communication. The difference between QoS 1 and 2, in QoS 1 there could be duplications. In QoS 2 there's no duplications, it only sent once, but that once is guaranteed. MQTT protocol is widely used in many domains, even outside IoT. So Facebook messaging has been using MQTT at the initial phases. Amazon Web Services use Amazon IoT with MQTT. Azure IoT from Microsoft Hub also use MQTT as their protocol. Everything IoT platform also use MQTT. And Adafruit, electronic manufacturer, launched a free MQTT-based cloud service to support their IoT hardware for the experimenters. So most of the IoT cloud platform providers support MQTT as one of the preferred ways to get data from IoT devices.